Go ahead and look at this in the recording. Let's solve actually 3 by 3, a bigger question uh, in the live session, and then you can see in the recording or in the PPT the other question. So this is our question that we have to maximize 8x1 plus 10x2 plus 7x3 subject to this less than equal to constant such that x1, x2, x3 is greater than 0. So what is the first step? So we will solve it in Excel, but to get there, let's first just make the table ourselves. Then we'll go to the Excel. So can anyone tell me the first step? Okay. Yeah. So wait. Just I don't know whether you guys can you guys turn off your microphone? I don't understand this. Okay. I think you can. Yeah. Yeah, Pankaj, you can turn off. Yeah, I see that you can turn off your microphone. Do you want to tell what will be the first step? Yes. Okay. So the only non-standard that we see here is that it is said that it is in maximization. So that's what we'll do. We'll convert this problem to standard form, that is minimization. And I have gone ahead and I have added the so okay. Now tell me, what is this x4 and x5 that I have added here? Yes. So we call it as slack variable. The terminology is not that important, but yeah, we call them as slack variables. We have added them. So to remove this inequality sign. And these slack variables are also supposed to be greater than or equal to 0. So okay. So can anyone tell me what is the initial basic solution for this particular thing? What should we choose as an initial basic solution? Okay, maybe I should not have skipped that first equation. I skipped it since it was easy. Let me go back and yeah. So what is a don't mind this. We have just come back here to see what is the basic variable and non-basic variable. So what is a basic variable and non-basic variable? So whenever we have, let's say we have five variables in a particular, let's take this itself. We have how many variables we have? We have x, we have y, we have x1, and then x2. So here itself we have four variables, and the equations are two equations. We have 3x plus 5y plus x1 equal to 78, 4x plus y plus x2 is equal to 26. Now we cannot solve this particular equation using this these two given equations. So what we do is we have two equations, so we can solve for only two variables. So we have to manually assign the other two variables some value and then transfer them to the right side of this equality sign and then calculate the value of other two variables. So when we do that and when we specifically assign the value for these two variables out of this four to 0, then we call them as non-basic variables. So the definition is easy to understand definition is the variable we set as 0 to be able to solve a set of equation. are called non-basic variables, and the other variables that we end up solving, are called basic variables. Okay. So for this particular question here, what we did was we set, see, we have two equations and we have one, two, three, four, five variables. What we do, we set x1, x2, x3 as 0, non-basic variables. Initially we say, okay, these variables are non-basic variables, we will set them as 0. Then x4 will be equal to 10 and x5 will be equal to 8. So the and f and so on, the value of f will be 0. So this is the initial basic solution that we get after setting the variables forcefully to 0. And this is the table. So how do we make this table? Let's see how do we make this table. So this is our first equation, right? Uh, just a minute. Yeah, so this is our first equation. So let's see whether we can say the first equation using this particular row. We have x1 plus 3x2 plus 2x3 plus x4 plus 0x5 plus 0f is equal to b. So this thing here, the row, the column of b is actually the right hand side, and all these things, all the other things, these are the left hand side, x1, x2, x3, x4, x5 and f. And similarly, we can see that we have our second equation also. See, x1 multiplied by 1 plus x2 multiplied by 5 plus x3 plus x4 multiplied by 0 and x5 multiplied by 1, then f is multiplied by 0 and is equal to 8. So is this clear now, like how we got this particular table? Because if this is clear, then we can go on to the excel and then we can try to solve it. Is this clear? Okay. So now let's go and solve it in excel. So, okay, so let me increase the size. Is this good enough? Visible, right? Okay. So this is our row one, row two, row three. Now what we do is initially we look at these variables x1, x2, x3, x4, x5. We don't go to this side. To the after f or f we don't consider. We look at these variables, and then we find out the minimum negative number. So the minimum negative number is here minus 10. What is this corresponding to? It is corresponding to x2. So that means we have fixed that x2 is going to move in. Now, which element is x2 going to replace? X2 is going to come to x4 or x2 is going to come to x5? We identify that by calculating the ratio of this b, the constant, that is the right hand side, with respect to the coefficients. Okay, so seems to me like I have lost the connection. Yeah, I apologize. I lost the internet connection. It's visible now. Voice is not coming. Okay, just oh. Is it coming now? I don't think it is coming. Can anyone? Oh, okay. The voice is coming now, right? Oh, I don't know why we both faced internet issue even though we are miles apart. Yeah. So yeah. So based on the negative, we selected that x2 is going to come in. Now, what is going to go out? We have to choose based on the ratio of this B column and the coefficients of x2. So that's what let's do it here. So is equal to a b by a is equal to this divided by this 3.3 here and 1.6 here. So which one do you guys think it is going to go up? Oh my god. Okay. Still hanging up. So how about if I zoom in this much? This is okay. Okay. So now you guys tell me what is the variable that is going to go out? X5, correct. So X5 is going to go out. So let's highlight them. X2 is going to come and X5 is going to go. And when that happens, so let me just do this here. Now when that happens, we have to remove this. So we will make a new table and we do X instead of X5, we will write here X2. Okay. And we will leave this particular row as it is. So let me remove this also. We have to calculate a new b by a here. So we will leave this row as it is. Now x2 has become a basic variable. So what we have to do is we have to see where is x2 meeting. So x2 comes from here and it comes from here. So except this particular uh, element, all the other elements in this yeah, tell me. So except this element here, 5, all the other elements, the 3 and minus 10, has to become 0. So we have to do some row operation for this R3 and R1 to make them 0. So since we have Excel at our disposal, let me just do a very rude operation. That is, let's do for R1. R1 is equal to R1 divided by 3 into 5 minus R2. Is this going to help us? What do you guys suggest? Yeah, let's do it. Is equal to this divided by 3 into 5 minus so we have 0.667 no need to worry about that we can just so yeah it has made this particular value as 0. So let's copy this and paste it here as a number. So now we can remove this. So we have done the operation for R1. Similarly, tell me what should be the operation for R3. Yeah, yeah. So yeah, R3 should be R3 plus 2 into R2, right? So let's get the value here also. So this is R3 plus 2 into R2. Can we extend it? Can we get this? Now we can replace the values that are here. So we have to replace as values. So now we have made all the other elements for this particular column as 0 and we have x2. Now one more thing that sir was doing in the lecture was he is making this as 1. But I suppose that we can make do without doing that particular, because uh, how do we calculate the value of x2 and how do we calculate the value of x4 is we will see now. Let's see that. So we have x4 and x2 as yeah, we have x4 and x2 as basic variables, right? So what will be the value of x1, x3 and x5? Can anyone tell me? So since we have now these two are basic variables, what will be the value of these non-basic variables? 0, correct? So when this is a non-basic variable and I have told that we can write the equation that we have seen here, we can write the equation by multiplying these things and make it equal to b. So let's see whether we can do that. We can do it here also. So in this particular first row, what we will see is 0.667 into 0 plus 0 into x2 plus 2.333 into 0, because let me highlight them with some make them italic because they are non-basic. So 0 into this constant plus this into 0 into this value, because it is not a non-basic, so it will not be 0. Anyhow, we have made this particular coefficient itself into 0, so this is not going to contribute. X3 is a non-basic, it is not going to contribute. Now x4 into 1.66 and x5 is again 0. F is multiplied with 0 is equal to 8.68. So basically we end up with this equation. It's x4 into 1.667 is equal to 8.668. 8.667. So what is the value of x4? The value of x4 we can write it as is equal to this divided by the coefficient of x4 in this equation, right? So this is the value of x4. And similarly, the value of x2, again when you do the same thing for x2, you will see that all these non-basic are 0 and the basic is multiplied by 0. So they are not going to contribute, only this x2 is going to contribute. So x2 will be 8 divided by the RHS, this thing divided by the coefficient on this particular. So it will be 5. That was x4 and this is x2. And what is the value of f? Can anyone tell me? Use the same concept. Multiply these things with the variables and tell me the value of f. Okay. So let's do it together. X1 is a non-basic variable, so 0 into minus 6. X2 has some value 1.6, but it is multiplied with 0. X3 is non-basic, so 0. X4 has some value 5.2, but it is multiplied with 0. X5 is non-basic, so 0. F is multiplied with minus 1. We don't know its value. So minus 1 F is equal to 16. So what is the value of F? Yes, correct. So similarly, what we did, no, we multiplied this B with their coefficient. So we have to do that. We have to divide this by this coefficient. So F value of F is minus 16. Is it clear? Okay. So now let's see whether we can. This is one solution. Whether it is feasible or not, that's let's not worry about that. That we have to check the. Yeah, so it is feasible. It seems feasible because x4 is greater than 0, x2 is greater than 0, and all the other variables are 0. It may be satisfying the constraints. But let's see whether we can improve it or not. Can we improve it? Can anyone tell whether we can improve it or not? Yes. So which variable should? Yeah. So which? Uh, Look again carefully and tell me. Yes. Correct. So x1 is going to come in because it is having the minimum negative coefficient. And to know which variable it is going to replace, we have to again do the b divided by the coefficients of this variable. So b this divided by coefficients of this variable. It is giving 13. What about the lower one? It is giving 8. So x1 is going to replace which variable? Yes. Yeah. So x1 is going to replace x2. It may seem a little bit weird that now only x2 came, how it is getting replaced, but that's what is happening here. So let me just highlight this so that it is clear whenever you guys are looking at it after some time. So let's highlight this minimum value, and this is going to replace this. Okay, now let's make a new table. So let's remove here x1. So, okay, now tell me which row is going to remain same and which row is in which row we have to make the coefficients of x1 as 0. Perfect. Correct. So that's what we will do here. So we have to let's write an operation for R1. R1 is equal to, can, anyone wants to tell? We can do complex division multiplication also. So no need to simplify the problem. Okay, so let me just write here. R1 divided by 0.6667 minus R2. See, this is the benefit of Excel. We can understand the concept here, and when we are doing in the actual problem, we can check whether it is going to. We can put some sensible numbers. We have calculators, we have all the gadgets, so we can do these operations also. So let's do that for R1. R1 divided by 0.6667 minus. So it is given very less value, even though it is not zero. We can say it is zero. So I am just going to replace that, and let's Control C and paste the value. So we have done the operation for R. Now what about R2? R2 seems to be simple. No, sorry, not R2. R3. You want to tell what will be for R3? So okay. So let me tell. R3 will be R3 plus 6 R1. Oh, no, R2, sorry. 6 into R2. Is it correct? R3, this is equal to R3 plus 6 into. So let's extend this. And we have got some paste value here. We will delete this. Now we have done the row operation and we have made these things 0. Fortunately, this was 1, so we will work out for everyone. Yeah, okay, now the basic variables are x1 and x4, right? So can you tell me the value of x4? Just tell me, don't tell exact value. You can tell me what divided by what. Okay, so let me just tell one again. Once again. Yeah, tell me. Pankaj, you wanted to say something? Yes, absolutely correct. Yeah. So it is going to be this divided by this. 1.99 is almost 2. It's actually 2 only. It's because of our approximation, it is coming as 1.9. And similarly, x1 is going to be, x1 is straightforward, right? Again, 2 divided by the coefficient of this variable, that is this variable, this. So x1 is here. And the value of f, what is the value of f? Yes, but this value of x is minus 16. So now we have this new basic solution, and others are of course others are 0. So is there any scope of improvement now? Yes. Okay. So since there is, we will write here that there is no scope of improvement. So then this is our solution. So x1 is 8, x2 is 0, x3 is 0. So these were the variables that were originally present in the equation. So we will stop here because x4 and x5, those were the slack variables that we introduced. So this is the solution for this particular question, and maximum value of f, that was the intention, is going to be 64. Correct? Yeah. So this is how we need to solve. So I actually, my voice is, oh man, I don't know why this is happening. My voice is audible, right? I again lost the connection for some reason. Okay, so this is how we solve. Okay, so this is how we have to solve this equation. So I'll be sharing this Excel sheet because I have in the PPT. I have one more question that is a little bit easier than this, and it is a more detailed actually. So you can go ahead and try to solve it. And I will share this Excel sheet also in that particular Google Drive that is shared with you guys. So in there I have solved this one, and one more problem which I would like you guys to solve. I will give a hint about this problem, and I will share this thing, and it is solved in the PPT also. So you guys can go ahead and try it. Yeah. So let me discuss about that problem. We'll not be able to solve it. Just let's discuss. So let's say we have this particular problem. We have to minimize f is equal to a 40x plus 51, subjected to this greater than equality constraints. Okay. So how do we go about solving this? What we do is we introduce some slack variables, x1 and x3 we have introduced to remove the inequality sign. Till this part, is it clear? Okay. Then we have introduced these things. We make the table. So this is how the table will look like, right? 30 into x. This particular row is going to replicate this equation. This particular row is going to replicate this equation, and this particular row is going to replicate this equation. So 30x plus 40y minus x plus 0x3 plus 0 f is equal to 2000. And similarly 50x plus 40y 0x1 minus x3 plus 0 is equal to 300. And when you bring this f to the right hand side, or you bring, this f to right hand side, and it becomes minus 1. So 40x plus 50y plus 0x1 plus 0x3 minus f is equal to 0. So now tell me how we will choose which variable comes in and which variable goes out. There is a problem here, right? Can anyone tell me what is the problem? I have written it here also. You tell me whether do you think this problem is valid or not. Yeah, so actually there is scope of improvement. Uh, and But we are not able to see what we have discussed in class, and the example that I have also shown there. Whenever we had this minimization problem, somehow for some reason we had a minus in front of the coefficients. You would have noticed that all the coefficients are negative, but in real life that will not be the case, right? We will have to minimize a problem that will have positive coefficients also. So then how do we do that? Because it is mentioned in the question that we have to choose the minimum negative, but there is no negative here. So how do we go about it? So then we will use the concept of. Do you want to tell Pankaj? Any idea? No, no, no. So that we cannot do actually. So we have to convert it into standard form, and the standard form is minimization only. So we cannot go back to indexing. So here we will use the concept, that is the concept of artificial variables. Okay, so this is what we will do. This is what we did, introduced slack variables, right? Now we will introduce two more variables, x2 and x4. Previously we introduced x1 and x3. So don't be confused. I introduced x3, not x2. So now we will introduce artificial variables, that is x2 and x4. But the thing is, already there was an equality sign. Now when we have added some artificial variables, this equality sign will be disturbed, right? So we will add one more function, which is going to be our new objective function. So we will call it as artificial variable function, which will be the sum of the artificial variables, x2 plus x4. Till here, is it clear? Okay, so now what we have to do, we have to minimize this function. But to minimize this only to x2 and x4, it doesn't make sense. So what we will do, we'll get the value of x2 from this equation. We'll just push all these things to the right hand side, and we'll get the value of x4 from this equation. Push all these things to the right hand side, and this is what we get. This is x2 and this is x4. So the our artificial variable function is actually now this one. So we have to minimize this function. Now we see some negative coefficients, right? So we can say, yeah, we can actually do it, right? Yeah. So now we have artificially introduced some negative coefficients because our problem requires us to do that. And okay, so and this will be the. So I will just show the first slide, so that you guys can understand how what is going on here. So you see here, this will be ACF. So what we have to do, this is our first equation. This is our second equation. This will be our third equation when we send the f to the right hand side, and this will be our fourth equation that we have to write in the table. So for that, we will send this 5,000 to the this side and this ACF to the right hand side, and this equation will be written in the table form as this. So our first inequality constraint is was 30x plus 40y minus x1 plus x2, and all these things 0 is equal to 2000. Second was 50x plus 40y, then minus x3 plus x4, and is equal to 3000. And the objective function, the old objective function that we are minimizing in the previous examples, is also written here. 40x plus 50y, all these variables 0, minus f is equal to 0. And this is our new function that we are going to minimize, that is the artificial variable function. So it is going to be uh, minus 80x minus 80y plus x1 plus x3 is equal to minus 5,000. Is it clear that why minus 5,000 is coming? Because we sent this to the other side and brought this to this side. So this will become minus 5,000 and this will remain minus 80 minus 80y. That is clear, right? Uh, you have to say if it is not clear. Okay. Yeah. So now this is our new table. When we go about doing all the old stuff, it's again we ignore these. After f, we have to ignore. We have to check in this particular row whether there is a negative. So we have minus 80, minus 80. Both are negative. We choose anyone at random and do the row of, and we chose the x. That means this particular x is going to come in. And again, which is it going to replace, either x2 or x4? See, remember, do not count this f in with these variables. I When I was solving by mistake, I did this, counted this, and tried to replace that itself. So only see the variables. So at present, one thing I forgot to mention is when you are minimizing this artificial variable function, then the basic variables actually are going to be x2 and x4, that we can see from this particular table also. See this table, you have x2 coefficient as 1, all the other things are 0. You have x4 coefficient as 1, all the other things are 0. So x2 and x4 is actually going to be the basic variable in the initial stage. And then we saw that minus 80, that means x is going to come in. And then based on this ratio of 2000 by 30 and 3000 by 50, we decide which one is going to be replaced. So we found out that x4 is going to be replaced. So then we do the row operation. We can do it in Excel. I will share this Excel also. We have to do the row operation and we have to replace the x4 with x, and yeah, so you get this. So you get the idea that how we are going to solve. So basically, when we after we have successfully uh, minimized or successfully improved the artificial variable function, you will find that its value has to will come to zero. And you have to remember this, that always the value of this artificial variable function has to come to zero. Can anyone tell me why? So it may be a little bit confusing, but the reason is this: we had already had equality sign, then we added some artificial variables that will disrupt the sign if it has any magnitude, right? X2 and x4. This is going to disrupt the sign of this equality if it has any magnitude. So the artificial variable has to come to zero. Then only this initial equality sign will be valid. Is it clear? So basically, when you are doing all this row operation as we did with f, we are doing it again with the AF function, the artificial variable function. You will see that whenever you don't have any scope of improvement, as in this case, all the coefficients are positive or either zero, then the value of the artificial variable function will go to zero. If that is not happening, then you have to check, because there might be some kind of error in the calculation. So now when we have successfully optimized the artificial variable function, then we what we do is we remove the artificial variable and the artificial variable function from this particular box, and then we go and try to improve the do the same thing that we did earlier with the f. Right now we have removed this, we get this new box. After removing the x2, after removing the x4 and this a, we get this our old box that we like, and in which we try to find the minimum. So now we have to again improve the f. So can you tell me, is there any scope of optimization of this f further? Yeah, so luckily this happened, and in example, sir has also I think showed one artificial variable problem, in which even after this function was optimized, there was a negative in the x, or some variable was negative, right? So we had to optimize f for one more step. So that can happen. So one thing to note is, after optimizing the artificial variable, make sure that you are checking this whether f has any scope to be optimized or not. Okay, so in our example, we got lucky that there was no scope, and this we can just simply get the value of x by dividing this b with the coefficient of sorry, here it is the x, no? So dividing this b with the coefficient of x, and we can get the value of y by dividing this b with the coefficient of y, because all the other variables are 0, and you can get the value of f by dividing this b with the coefficient of. So this is basically a question that I also struggled with. I was also thinking maybe we can convert this problem to maximization, but it didn't work out. So this is the proper way to solve this. That was probably not covered in the lecture. So I thought this is important to cover. And you can also go ahead and step by step see how I have solved it in the shared Excel file that I will